Bismillahirrahmanirrahim. Our sixth chapter, you can say, is cross drainage works. Or cross drainage structures. When we say this term, cross drainage structures or cross drainage works, which thing comes in your brain?
Siphon?
Is it culverts?
Culverts. Okay. Which subject we are studying now?
Hydraulic engineering.
No, yeah, irrigation engineering.
Sorry, engineering. Irrigation engineering.
Okay, irrigation engineering. And irrigation engineer, you know, he designs, plan, designs and construct canals, irrigation channels, which you have designed as our first chapter. Okay, design of canals. So canals are man-made structures. Canals are basically designed by us, by engineers. And you know, the river network was natural and is natural, which was existing and which is existing even now. And if I want to design a canal, then I have to propose some canal layout. And you know, the drainage means streams, natural streams or rivers. Those are already existing. So when I plan or I design the layout of a canal, so my canal will cross at many locations to the already existing streams or rivers, which are called as drainage. So I have to cross my canal over the drainage or below the drainage or at the same level of the drainage, and whatever are the hydraulic structures which we construct at the crossing of the canal and drainage means the stream or river. So those hydraulic structures are called as cross drainage structures or cross drainage works. Is it clear?
Yes.
Yes, sir.
Okay, now we can go to the next. Here the definition of the cross drainage structure is given, which we have already discussed. So let us read it. A cross drainage work is a structure which is constructed at the crossing of a canal and a natural drain, stream, river, so as to dispose of the drainage water without interrupting the continuous canal supplies. So that is a cross drainage work or cross drainage structures. So these cross drainage structures, these are costly, expensive. So what we should try? We should try to reduce their numbers as much as possible, you know, for the whole design of our canal system, canal network. Canal network does not mean only the main canals. There would be then branch canals. Then there would be minors and distributaries. So all these canals may be at some locations, they have to cross the existing streams. And we have to provide hydraulic structures over there. So we should try to minimize them. Our layout should be such that it should cross to these drainage lines as minimum as possible. So how we can reduce the number of cross drainage structures? So numbers can be reduced by designing the proper alignment of the canal and by joining small drains. Okay, if we are designing the layout of the canal network in a proper way, then we can reduce the number of cross drainage structures. And second way is we can join very small drains, 2-3 drains into a one, on only one cross drainage structure can be provided by collecting the waters of these 2 to 3 very small streams. Is it okay? Clear? Shall we move to the next slide?
Yes, sir.
So you can see that this is a picture which shows that how canal is aligned along a ridge line or watershed line. So if in this figure, these are the two major rivers which are moving. Whereas somewhere here, we have constructed a headwork or a barrage, and a canal has been off taken from here. So this is which canal? Branch canal or main canal?
Main canal,
Main
sir.
canal, sir.
This is the main canal. This is the main canal, which is off taking from this point. And then after this point, now this canal we have aligned along the ridge line or watershed line. What is watershed line? The peaks in the area. Okay. As long as this canal is aligned along the ridge lines or on watershed divide line or on watershed line, what do you think? Is there any possibility that some drain or some stream will cross it? Ranjit, what do you think? Now, you know, this is the ridge line. So these are the small drains or streams which are in this direction and also in this direction. We know that the streams are along these slopes. So these are the streams. So once we offtake a canal here, and then we may come across many crossing points. So this is C1, cross drainage structure 1 required here, C2, C3, C4. But as our canal reaches over the ridges, then no minor drain or stream is going to cross it, and we can save the money which we have to spend on the cross drainage structures. But you know, this much this alignment was unavoidable and we have to provide it. So that's why we need these cross drainage structures and we have to provide it. Is it now clear? What is the importance of providing a canal over the ridge lines or watershed line? So what are the two main? Yes, if you have any question.
No, sir, I was just responding.
Okay. So now I have one question. What are the two main advantages of providing a canal over the watershed line or over the ridge? What are the two major advantages?
Avoid
Sir, there is a
cursing for
command
stream
over the
source.
area.
Yes. One is we have a better command over the area which is to be irrigated, because we can easily provide the water through gravity flow. What is the second advantage? Yes. Second advantage is along the ridge line, we don't find streams which will cross to the canal. And so we don't need cross drainage structures. Okay.
Economy.
So this would be economical. All right, now we will move to the next slide. Now, whatever we have discussed about the cross drainage works, the same is mentioned here. So we can read it. Irrigation canals, while carrying water from head works to crop field. It means all type of canals, main canal, branch canal, distributary and minors have to cross few natural drainage streams, nalas, etc. To cross those drainages safely by the canals, some suitable structures are required to be constructed. So works required to be constructed to cross the drainage are called as cross drainage works. At the meeting point, a crossing point of canals and drainages, bed levels may not be same. Their bed level may not be same or may be same. Depending on their bed levels, different structures are constructed and accordingly they are designed by different names. So what is the most important thing? Are the bed levels. Where is bed level? This is bed levels. Bed levels are very important. What is the bed level of the canal? What is the bed level of the stream or river? So depending on that, we have many types of the cross drainage structures. Now, what is the necessity of the cross drainage structure? That we have already discussed. The watershed canals do not cross natural drainages. This we already understood from that figure. So watershed canals means those canals which are provided along the ridge lines. But in actual orientation of the canal network, this ideal condition may not be possible. Okay. And the obstacles like natural drainages may be present across the canal. So the cross drainage works must be provided for running the irrigation system. Now at the crossing point, the water of the canal and the drainage can get intermixed. Sometimes we can intermix them. So for the smooth running of the canal with its designed discharge, the cross drainage works are required. You know, the side condition of the crossing point may be such that without any suitable structure, the water of the canal and drainage cannot be diverted to their natural directions. So the cross drainage works must be provided to maintain their natural direction of flows, as the canal should flow in its way and the river should flow in its way. Now let us come to the types of the cross drainage works. As far as types are concerned, we have three types. Type 1 cross drainage works, type 2 cross drainage works, and type 3 cross drainage works. What are type 1 cross drainage works? In these cross drainage works, the canal water is being passed above the stream. Okay, so canal is passed above the stream. Whereas in case of type 2 cross drainage structures, canal is crossing the drainage below the drainage. So, and in type of 3, the canal is crossing to the drainage or to the river in such a way that their levels, they are more or less same, and their waters, they are intermixed, and that is called as type 3 cross drainage works. Is it clear?
Yes, sir.
So there are three types. In type 1, there are two types of the structures. Number 1 is the aqueduct, and number 2 is the Siphon Aqueduct. In type 2 cross drainage structure, there are further two types of structures, Superpassing and Syphon Superpassing. And in type 3, there are two again subtypes of the cross drainage works. Number 1 is the level crossing, and number 2 inlet and outlet. So in total, how many are the cross drainage structures which are usually possible in our irrigation canal system?
6.
6. What are their names? Aqueduct. Number 2, Siphon Aqueduct. Number 3, Superpassing. Number 4, Siphon Superpassing. Number 5, level crossing. And number 6, inlet and outlet. So these are the 6 total possible number of cross drainage works or structures. Now let us discuss one by one. Before starting, let us discuss these points which are very important for the selection of type of cross drainage works. So these are the few points which are very important. Number 1 is the relative bed levels. This is the most important in case of selecting the type of the cross drainage works. What are the relative bed levels of the drainage and of the canal? The next very important thing is the discharge of the drainage. So this is the number 1 most important factor. This is the second. How it depends on discharge. If the discharge of the river is very high, then what do you think? The width of the river is higher? Kyonji?
No, sir, width would be narrower.
No, if the discharge is more. If the discharge is more, the width increases with discharge. What is the the wetted perimeter formula by Lacey? 4.75 root of discharge, है ना? तो perimeter जो है, width जो है of the channel in alluvial plains, that is proportional to root of discharge. ऐसा ही है या नहीं है?
Yes, sir.
Yes.
If the discharge is more of a river, its width would be more. And when its width would be more, और मैं cross drainage structure बना रहा हूँ, तो वो जो length होगी of the culvert या of the the trough, वो कम होगी या ज़्यादा होगी?
ज़्यादा होगी, sir.
That would be more. So there is a possibility of more expensive cross drainage structure if the discharge of the drainage is more. Okay, so what is the next? Next, number 3 most important thing is economical consideration. So if we have several options, then what we will do, we will compute their costs, and then we will provide which has the lowest cost. That is the economical considerations. And then the next is number 4 is availability of suitable foundation. At certain locations, the foundation material is very weak, and then we have to maybe avoid it, or we have to make its improvement. And then number 5, there may be some construction problems at site, maybe climatic factors, rainfall, etc. And sometime, during the construction, if there is a lockdown, okay, these are some practical problems which may come across during construction process. Now let us discuss in detail all these 6 the cross drainage structures. Number 1, in type 1 aqueduct. So what is an aqueduct? You know, it is a hydraulic structure in which irrigation canal is crossing or taken over the drainage. So drainage is flowing below and the canal water is crossing it above the drainage. So that structure is called as aqueduct. Is it clear?
Yes, sir.
Okay. Now the question is, when this structure we will provide? So this structure is suitable when bed level of canal is above the highest flood level of drainage. So this is simply, if this condition is satisfied, we have to provide an aqueduct. Okay, and you know, in this case, drainage water passes clearly below the canal, clearly below the canal. So it has a free surface. Now let us try to understand. Now this one is a stream or a river or a drain which is flowing in this direction. This is the bed of the stream. And what is SBL? There are 4 levels here. It is shown 4 levels. What is the first level? SBL. SBL stands for stream bed level. So this level is called as stream bed level. Then this level is called as HFL, high flood level. Okay, and this high flood level we will determine on what parameter? You know that when the charge is more, the high flood level is more. When there is a bigger flood will come, this level would be higher and higher. So which flood we have to take? We have to consider.
Sir, 50 years or 100 years return period.
Actually, we have to consider this stage on the design flood. जो भी design flood होगा for this cross drainage structure, if it is 100-year return period flood or 500-year return period flood, whatever is that. So वहाँ पर जो ये level होगा, that is called as high flood level. And what is the next level? The canal bed level, CBL. And what is this level? This is not high flood level. There is no flood in canals. In canal, we control the supply of water to the canals. So the flow is regulated in the canals. तो इसलिए ये कौन सा level होगा? This is FSL, full supply level. Reverse में full supply level नहीं होता, full reverse में होता है high flood level. But in canals, it is full supply level. So when
Sir,
जी
सर कुछ मतलब समटाइम्स सर कैनाल्स भी तो कर जाते हैं ओवरफ्लड, बैंक से मतलब ओवरफ्लो करते हैं, इसकी क्या रीजन होती है फिर?
No, that is, it means there is some negligence of the barrage, वो जो gate operator है ना, उसकी negligence है. So either he, for example, if there is rainfall, if in Lahore suppose there is 80 millimeter rainfall has come, तो क्या है 80 millimeter directly the stage at that time will increase in the canal. Are you sure? क्या ख्याल है?
यस सर.
तो वहां पे जो बैठा है हेड रेगुलेटर ऑफ मेन कैनाल में, उसने 80 मिलीमीटर से जो स्टेज लाने के लिए जितना डिस्चार्ज चाहिए, सो ही हैज टू रिड्यूस दैट डिस्चार्ज. ओके, सो प्रॉपर regulation of the barrage is required, and also the head regulator of the main canal. So that may be a negligence, but normally we control and there are no floods. As far as you are saying that sometime it breaches its banks, that is something else. For example, due to buffaloes and due to rats and rabbits, you know, they scratch the banks, and when there is a rainfall, then they weakens, and then maybe a piping starts, and the whole of the bank may be breached. So that is a separate story. और ये क्यों हो गई? क्यों भाई? Again, it is due to negligence of the irrigation patrolling staff. जो पेट्रोल कर रहे थे, पेट्रोलिंग कर रहे थे, उन्होंने पहले क्यों नहीं देखा? You know, whenever this problem has arisen, even at that stage, you have to take measures. और अगर आप उसको होने देंगे, तो आहिस्ता 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 the problem will become bigger and bigger. Is it clear, जी?
Yes, sir.
Okay. So aqueduct, when aqueduct we will provide? When the canal bed level is sufficiently higher than the high flood level of the stream. Then the, और अगर ऐसे canal cross कर रही है, तो the structure which we will provide is called as aqueduct. This is one model of the aqueduct. तो ये क्या है? What are these? These are the two piers. Piers. And you know, this stream is flowing like this. तो stream इसका कोई वो होगा ना? You know, what is this one? Water level, है ना? ये flow कर रही है ऐसे. And this is a canal is crossing like this, but in such a way that the bed level of the canal is higher than the highest high flood level of the stream. तो ये structure अब कौन सी है? This is the aqueduct. And these are called as RCC troughs, rectangular troughs. ये troughs है ना, rectangular troughs हैं, इसके अंदर water is flowing, and here we may provide a slab which will act as a road, and this, you know, the road is required for patrolling of the structure. And you know that there are roads along the canals. Even Lahore की जो canal है, उसमें भी there are roads on either side. This is one more section of the aqueduct, and this is the direction of flow of the stream. This is the bed of the stream, and this is the high flood level, and this is the level of the bed of the canal, and this level is much higher, and this canal is crossing like this. So this structure is called as aqueduct. So this is a rectangular concrete trough, okay, which carries canal water. And on the side we can provide an inspection road. So this is an example of the aqueduct. Now you can see that in this figure, this is a canal. It's a major canal, and below it a river is flowing, and you can see that these are the piers of the river. ये pier नजर आ रहे हैं of the bridge, yeah, of the aqueduct. So this structure is aqueduct, and you know the highest flood level may be here. Can you see the highest flood level? In this photograph, can you see the flood marks?
Yes, sir.
नजर आ रहे हैं? You can see here. These are the flood marks. This is the highest flood mark. So that's why we say that water leaves its flood marks, and only the experienced people, they can recognize or they can locate, oh, that this is the highest flood marks. So we can say that if this is the highest, this is the high flood level, and the bed level is somewhere here of the canal, and this canal is crossing, तो ये कौन सी structure होगी? This would be aqueduct, because the bed level of the canal is much higher than the high flood level. All right, and you know this canal and the river, ये river भी use हो रही है किस लिए? For transportation purpose, and these are called as waterways. You know there are 4 means of communication. Number 1 is the कौन सी है भाई? Highways.
Road travels.
Highways जिसको road, and the second is airways.
Airways.
Third is
Waterways.
railways, and the fourth is waterways. Waterways means the transportation and canals and rivers in the ocean. Okay, that all is waterways, and you can see that there is a very beautiful system of waterway transportation. You can see that how many are the passengers they are waiting for these boats. Anyway, this is an aqueduct. Okay, let us see this figure. So this is the BS Link Canal in Pakistan, which is flowing in this direction. And in this BS Link Canal, what is BS? What is a link canal?
2 rivers को join करती है
जी, एक river से पानी, it supplies water from one river to another river. अच्छा, तो BS क्या है?
सिर्फ बलोकी
सुलेमान की लिंक कैनाल, बलोकी से शुरू होती है, सुलेमान की में डिस्चार्ज कर रही है ये पानी. And so its HF, its full supply level may be here. Right now there is less discharge, लेकिन इसका full supply level यहाँ पे होगा. Now this one major, we have made one more canal. एक ये canal है, ठीक है? So this was an existing canal. So an existing canal we will consider as drain, and this canal, let's say we have recently designed and constructed. So when the bed level of the canal would be higher than the full supply level of the another canal, or the high flood level of the river. So in this case, it is not river, it is also a canal. So in this case, if the bed level of this canal is higher than the full supply level of the lower canal, then this structure is also called as aqueduct. Okay, so it depends which canal you are constructing at a later stage. So now I think the concept of aqueduct is clear. Okay, क्योंकि कब provide करते हैं aqueduct?
The bed level of canal काफी ज़्यादा हो, full flood
is higher than
the highest flood in the river.
High flood level in the river. Yes. So now let us discuss the Siphon Aqueduct. Now this is also again a hydraulic structure where the canal is taken over the drainage. River के ऊपर से जा रही है canal, लेकिन कैसे? But the drainage water cannot pass clearly below the canal. इसका मतलब है bed level जो है canal का, it is not above the high flood level, it is slightly lower than the high flood level. उससे क्या होगा? Then the water has to flow under it, okay, with siphonic action. साइफोनिक एक्शन से फ्लो करेगा, यानी कि द वाटर नाउ विल फ्लो अंडर प्रेशर। अब ये क्या, एक कंड्यूट के अंदर, इन ए क्लोज कंड्यूट, नाउ द वाटर विल फ्लो। पहले क्या था, दैट वाज एन ओपन चैनल फ्लो, ओके। सो इट इज नोन एज साइफन एक्वेडक्ट, क्योंकि उसमें साइफोनिक एक्शन हो रहा है, इन्वर्टेड साइफोनिक एक्शन, दैट्स व्हाई इट इज कॉल्ड एज साइफन एक्वेडक्ट। सो ये कहाँ प्रोवाइड करेंगे स्ट्रक्चर, दिस स्ट्रक्चर इज सूटेबल व्हेन बेड लेवल ऑफ कैनाल is below the highest flood level. All right, so now we will try to understand from this sketch, and this is a stream, and this is the high flood level in the stream, which is above than the canal bed level. But anyway, canal is crossing above the stream. बहरहाल कैनाल ऊपर है, लेकिन उसका जो बेड लेवल है वो उसके हाईएस्ट फ्लड लेवल से या हाई फ्लड लेवल से नीचे है। देन दैट स्ट्रक्चर इज कॉल्ड एज साइफन एक्वेडक्ट। नाउ दिस इज द वन क्रॉस सेक्शन ऑफ द साइफन एक्वेडक्ट। सो द स्ट्रीम इज फ्लोइंग लाइक दिस। सो दिस इज द बेड लेवल ऑफ द कैनाल। तो भाई यही है ना, so this one is the bed level of the canal, and this is the highest flood level. So which is higher? So bed level of the canal is slightly lower than the high flood level. So this is the canal bed level. Now we provide a little depression here, and the water and you know, here this water in a stream is flowing as open channel flow, but when it enters under the slab, so here it is pipe flow, okay, and then water emerges out, and again this becomes open channel flow. So this is called as Siphon Aqueduct. So when we have to provide a siphon aqueduct, then of course canal is flowing or crossing above the drainage, but in such a way that the canal bed level is slightly lower than the high flood level. Then we have to provide siphon aqueduct, and here the water is flowing under pressure, because this is a pressure conduit, it becomes a pressure conduit. Now come to the type 2 structures. What are type 2 cross drainage structures? In which the canal passes or crosses below the drainage or below the river. Yes.
सर पिछली स्लाइड पे क्वेश्चन था।
हाँ जी।
ये क्रॉस सेक्शन की समझ नहीं आ रही पियर वाली पोजीशन से। अगर हम क्रॉस सेक्शन काटें कनाल का तो पियर तो एलिवेशन में नजर आएगा और फुल एक रेक्टेंगल होगा कनाल के नीचे, जो आपने पीछे मतलब रियल स्ट्रक्चर दिखाए हैं। तो यहाँ की क्रॉस सेक्शन की समझ नहीं आ रही कि पियर्स दो कैसे नजर आ रहे हैं।
No, actually this is the cross section of what? कैनाल का क्रॉस सेक्शन है, ओके। तो कैनाल यूं आ रही है, दिस इज द ट्रफ ऑफ द कैनाल। पीछे से कैनाल की शेप कौन सी थी? ट्रेपेजॉइडल, है ना, और बड़ी थी। हमने उसको क्या किया, फ्लूम किया, छोटा किया है कैनाल को, ताकि फॉर इकोनॉमी पर्पस। सो इट इज मेड ऑफ कंक्रीट। सो दिस इज द आरसीसी रेक्टेंगुलर ट्रफ which carries canal water and these are the pillars या piers हैं, ठीक है ना। अब ये piers की क्या डायरेक्शन होगी? ये piers ने यहां से आना है ना पानी। these piers will be for river water। तो इनकी शेप क्या होगी piers की? अगर मैं प्लान में देखूं, I'm sorry, oh yeah, ओके ये अगर मैं प्लान में देखूं ना पियर्स की शेप तो वो ऐसे होगी ओके क्योंकि पानी इधर से जा रहा है ना the water
Yes.
is moving like this okay तो ये piers हैं and these will be many piers which are carrying this rectangular concrete trough
सर मगर पिछली स्लाइड पे जो हमने कुछ पिक्चर्स देखी हैं उनमें तो पियर पूरी कैनाल के क्रॉस सेक्शन के अंदर सिर्फ एक ही था, यहाँ पे ये दो बन रहे हैं।
no what do you mean by एक ही था मतलब ये है कि if you want to provide this whole one pier that is also possible देखो
Okay,
if you want to provide डिपेंड्स ना आप खर्चा करना क्यों चाह रहे हैं ये देखो ये मैं पूरे का पूरा पियर भी दे सकता हूँ ऐसे ऑफ दिस शेप तो बट यू नो दैट इज हाईली अनइकोनॉमिकल इसका इतना लोड नहीं है and that I should provide a very long pier but if there is
I was
a very
relating this
heavy
to the previous picture.
हाँ जी
Actually, I was relating this cross section to the previous pictures जो कि
हाँ
आपने शो किए हैं slide.
okay but actually you have options you can provide a pier like that वो कोई मसला नहीं है हैं?
Okay, sir. Thank you.
Actually being a designer you should design any structure economically
Right,
now
sir.
next जो टाइप 2 की स्ट्रक्चर है उसका क्या नाम है Siphon Superpassing now we would like to discuss the Siphon Superpassing this one what do you mean by Siphon Superpassing पहले तो superpassage का पता होना चाहिए so in case of superpassage the canal water the canal is crossing below the drainage or river but in case of siphon superpassage again the canal water is passing below the drainage or river but you know the stream bed level जिसको हम SBL कहते हैं stream bed level is slightly lower than the full supply level of the canal बात समझ आ गई है भाई so that's why the canal water will flow through siphonic action okay and there will be pipe flow. The flow would be under pressure in that barrel. Previously, the canal flow was open channel flow, and even after the superpassage in the canal, the flow would be open channel flow, but only in that portion it is as it is flowing full. So that is the pipe flow. Are the flow with siphonic action तो जी सारा वही लिखा हुआ है जो मैंने अब आपको एक्सप्लेन किया है shall I read it क्यों भाई you know what is superpassage it is a hydraulic structure in which drainage is taken over the irrigation canal यहाँ पे लिखा हुआ है drainage but I think we should say in terms of canals क्योंकि drainage तो पहले ही से थी drainage was already existing so what we are designing a canal network तो हमें क्या कहना चाहिए is a hydraulic structure in which canal is taken under the irrigation under the stream okay and is known as superpassage or the structure is suitable और ये कब suitable होगा भाई when the bed level of the drainage is above the full supply level of the canal as we have discussed earlier the water of the canal passes clearly below the drainage like this so this is the drainage and this is a canal, and the canal water will flow under the drainage, but in such a way the bed level of the drain is lower than the full supply level in the canal. All right, जी? तो अब हम क्या डिस्कस कर रहे हैं? सुपर पैसेज या साइफन सुपर पैसेज? Have we discussed super passage?
Yes, sir.
तो super passage क्या है जी? Super passage, when we will provide super passage, when the full supply level of the canal is below than the stream bed level, इससे नीचे है, then we will provide a super passage. तो कैनाल का पानी नीचे से गुजर रहा है और स्ट्रीम ऊपर से जा रही है. So this is the section, and here this is the full supply level of canal, और ये एक stream है, and this is the high flood level in the stream, and this is the bed of the stream, and this bed of the stream is higher than the full supply level. So then we have to provide a super passage. Now we have to discuss siphon super passage. अच्छा वो हमने siphon मैं समझा हम पहले ही siphon पे चले गए. So now we will discuss siphon super passage. तो siphon super passage क्या है? Super passage means a canal is crossing below the river. And what is a siphon super passage? It is crossing below, canal is crossing below the drainage in such a way that the bed level of the stream is slightly lower than the full supply level of the canal. So water flows under the stream in siphonic action. So that is called as siphon superpassage. So a hydraulic structure in which the drainage is taken over the irrigation canal. So again, instead of saying drainage, you should say canal, because you are designing canal. So canal is taken under the drainage, but the canal water passes below the drainage under siphonic action, is known as siphon superpassage. And when this structure is suitable, कब provide करनी है? The structure is suitable when the bed level of drainage is below the full supply level of the canal. Then the structure provided is siphon superpassing. Now here it is the explanation. Now this canal is crossing below the stream. कोई stream इस तरफ से जा रही थी, अब इस canal को हमने इसके नीचे से पास करना है. But the condition situation is that the full supply level of the canal is higher as compared to the stream bed level. Yeah, stream bed level is slightly lower than the full supply level of the canal. Then the structure, then what we have to do, we have to siphon the canal water under this stream. And this is the section of the siphon superpassage. So this is the canal full supply level. And here there is open channel flow. Here is again open channel flow. And this canal bed is slightly depressed here to accommodate this much flow. So when the water goes here, then it is the pipe flow becomes, because the flow is flowing full. And again the water comes out from here, and then again the open channel flow takes place. So what do you think? This full supply level here and here would be exactly same before and after the this siphon superpassage?
Yes, sir.
हाँ जी,
सेम होगा सर.
सेम होगा या स्लाइटली नीचे होगा यहाँ पर ऑन डाउन स्ट्रीम साइड? Slightly. What do you think? Yes, it should be slightly lower. जो full supply level यहाँ है उससे मामूली सा कम इधर होगा, maybe 0.01 foot like that. लेकिन क्यों? Why? Yes, वजह कोई वजह है?
लॉसेस हो रहे होंगे कहीं से।
Yes, due to head losses. Though these head losses would be very minor, but there would be a slight decrease in the full supply level here. Okay, तो क्यों जी अब समझ आ गई साइफन सुपर पैसेज की? कैनाल हम क्रॉस कर रहे हैं below the stream in such a way that the stream bed level is lower than the full supply level of the canal, and then the water flows under siphonic action under the stream. This is a very good section of a canal siphon, simply canal siphon, or we say that siphon superpassage. So a superpassage means the canal water crosses below the stream water. And why we say that siphon superpassage? Because here the bed level of the stream is slightly lower than the full supply level of the canal. And this is a barrel or a conduit in which now there would be pipe flow, and the water will come out from here, and again there would be open channel flow. So this is called a siphon. चूंकि ये कैनाल पे है तो हम इसको क्या कह सकते हैं? कैनाल साइफन. ओके, और साइफन सुपर पैसेज. क्यों जी, ठीक हो गया जी? आगे चलें.
यस सर।
Okay, before starting type 3 drainage structures, I think we would like to have 10-minute rest. ठीक है? Well, shall we start lecture? Are you back?
Yes, sir.
Okay. Now the third type of the cross drainage structure or the type 3 cross drainage structure are that one in which the bed levels of the canal and of the stream are more or less same and the waters are intermixed. Okay. So in type 3 cross drainage structures, there are two types. One is the level crossing. So first we want to study the level crossing. So when the bed level of the canal and the bed level of the stream are more or less same, and also the quality of the stream water is same as canal water, then we can intermix canal water in the river water, and the crossing is provided in such a way. Okay, that crossing is called as a level crossing. So let us read whatever is here. When the bed level of canal and the stream are approximately the same, and quality of water in canal and stream is not much different, then cross drainage work constructed is called level crossing. In this, water of canal and stream is allowed to mix. And then how do we control the water after mixing? So whatever is the canal discharge, it should flow in the canal discharge, neither less than that nor more than that. So how do we control it? So we control it with the help of regulators. So two regulators at least are provided, one on downstream of the river, another on downstream of the canal. Okay, and one more structure is provided, that is the crest wall. So these three structures are provided in case of level crossing to regulate the flow in the canal. Now this is the conceptual diagram which shows that when we have to provide a level crossing. Now this stream is moving in this direction, and a canal we are designing in this direction. And if the canal bed level and the stream bed level are more or less same, then we have to provide level crossing. This is the plan of a level crossing, a typical level crossing. So this one is the river and this one is the canal. So here you can see that two regulators are provided. One on the downstream of the canal, on the head regulator, downstream of the level crossing. This is called as canal regulator, and this regulator is called as a river regulator. So regulator means these are gates which are provided. And this is the crest wall. So what is the function of crest wall? Why a crest wall is provided on the upstream side of the river, upstream side of the level crossing in the river? Why a crest wall is provided? क्योंकि इसका क्या function हो सकता है?
To raise the water level.
हाँ जी?
To raise the water level.
What do you mean by raise the water level? What do you think? The water always, the quantity of discharge always remains same in the river?
No, sir.
So sometimes there are low flows in the river. When there are low flows in the river, तो जो canal water आएगा, here you have provided a regulator, so it cannot go to that side, but it may go slightly up for certain distance. जा सकता है ना?
Yes, sir.
So for that purpose, you have to provide a crest wall here. As in case of low flow season, the canal water should remain in the canal and it should not enter on the upstream side of the river. What is the second purpose? This was the one purpose. What is the second purpose? You know, the river brings a lot of sediments. So those sediments will be deposited on the upstream of the crest wall. And the water, when it will enter here in the canal, it has relatively less silt. Okay. So when the silt is more deposited, you can close this canal, and if the canal is closed, you can flush sediments from here. So that is the level crossing. So level crossing mein how many are the main components to regulate flow? 3 components. Number 1 is the crest wall, the canal regulator, and the river regulator. So this is one more layout plan of a level crossing. This is a drainage. Our river is flowing in this direction, and on here we have provided a river regulator or a barrage. Okay, and on this side we have also to provide a canal regulator, and sometime incoming canal regulator may be provided, but this is sometime provided, not always. So again, you know, the water from this canal comes here and then moves here, and then these 2 gates are regulators, control the flow in the canal. Now what is the next structure? Agli kaun si hai bhai? Inlet and outlet, which is type 3 cross drainage structure. What happens in the inlet and outlet when irrigation canal meets a small stream? You know, we are designing a canal, but there is a very small stream or drain at the same level, then drain water is allowed to enter in the canal at inlet. Inlet पे हम allow कर देते हैं कि भाई drain थोड़ा सा पानी है, okay, allow it to enter in canal, and at some distance from this inlet point on downstream, a part of water is allowed to drain as outlet, which eventually meets the original stream. So you should see this diagram. So this is a stream is already passing from here, but this stream size is very less. It means it carries very little discharge, and this is the canal which we are designing or we have designed, and this canal has sufficient discharging capacity. So what we can provide 2 structures. One is the inlet here and outlet here. So the stream water will enter in the canal, and on a certain distance downstream there would be an outlet, and the water will enter in this leading channel and ultimately will join the same stream. So this arrangement is called as inlet and outlet. So what do you think? Do we provide here some crest? क्यों जी crest चाहिए इधर कोई? Weir, है ना? As the canal water should not go in a stream, and similarly one crest is to be provided here with the, so when the discharge will be more than that level, so that will enter into the leading channel and finally will join the same stream. So stone pitching is required at the inlet and outlet. So we provide stone pitching here on the inlet and outlet, as these should not be washed out. The bed and banks between inlet and outlet are also protected by stone pitching. So stone pitching is carried out here on the canal. So that is the inlet and outlet. तो जी समझ आ गई बात? Is it
Yes, sir.
clear? Okay.
Sir, in previous level crossing, we will provide crest wall and canal regulator. Why we don't use the terms inlet and outlet there, where stream is crossing the canal?
Yeah. Actually, you know, in case of, in this case, inlet means a small quantity of water we are allowing to enter in the canal, and outlet means a small quantity of water as compared to the canal discharge we allow to take it out. Okay, here that is not the case. In this case, the river discharge is too much as compared to canal discharge. Okay, or it is comparable, maybe of the same magnitude, and that's why we allow to intermix, and we provide proper regulators, gates on the downstream of this crossing on the canal as well as on the river. So we don't say inlet and outlet. यहाँ पर तो हम बाकायदा inlet provide कर रहे हैं. So this is an inlet. Oh, so ये जो यहाँ crest level है उससे जैसे ही पानी ज़्यादा it will come in this stream, so it has to enter in this canal. And as the level of water is higher here and here lower, so there is again a crest, and the water will enter into the leading channel. So this is certainly outlet from the canal, and this is the inlet to the canal. And this much length of the canal we have to design on how much discharge? Maybe same canal discharge or more than that. क्यों जी?
More than that.
More than that. Suppose 20% of the canal discharge is coming from the stream. So the capacity of the canal here should be 125% of the canal discharge, only from here to here. Then again, the canal capacity would be same. Okay. So that is the concept of inlet and outlet. Inlet and outlet is provided when the stream size is small as compared to canal size. Okay. So till now we have discussed the 6 cross drainage structures. पहली कौन सी थी? Aqueduct. What is an aqueduct? In which the canal water or the canal crosses the river above the river in such a way that the bed level of the canal is higher than the high flood level of the stream. All right, then what is Siphon Aqueduct? In case of Siphon Aqueduct, the canal water passes over the drainage or over the river water, but the river water moves through siphonic action under the canal, and it is provided when the bed level of the canal is slightly lower than the high flood level of the stream. Okay, what is the third structure? That is the superpassage. A superpassage is a hydraulic structure in which is provided, or it is when the canal passes below the drainage, and it is provided when the bed level of the stream is higher than the full supply level of the canal. So that is called as superpassage. Now, what is the siphon superpassage? Now, it is a structure when a canal basically crosses these drainage under it, but in such a way that canal water is being siphoned under the river, and this is called as Syphon Superpassing. और ये कब प्रोवाइड किया जाता है? when the bed level of the river is slightly lower than the full supply level of the canal. Okay. What is the fifth hydraulic structure, cross drainage structure, which we have discussed? That is the level crossing. So in case of the level crossing, the bed levels of the canal and of the drainage, they are more or less same, and the waters are allowed to intermix, provided that if their quality is not much different. Okay. And what is the inlet and outlet? In case of the inlet and outlet is again provided when the bed levels of the stream and canal are more or less same, but the stream size or its discharge is lesser as compared to canal discharge. Then what we do, we provide an inlet to the canal and the water is allowed to enter into the canal, and then on a certain distance downstream we provide an outlet, and from that outlet extra discharge of the stream that is taken away in a leading channel. So these are all about the 6 cross drainage structures. Now we have to again discuss the selection of type of cross drainage works. Actually these some of them we have already discussed. Number 1 is the relative bed level, and you know the relative bed level is the most important, and it is the relative bed levels which decide the type of the क्रॉस ड्रेनेज स्ट्रक्चर है ना, तो ये मोस्ट इंपॉर्टेंट है. In addition to that, following points should be remembered while recommending the type of the work. Number A, the crossings should be at right angles to each other. Why? क्यों जी? Canal जो पास कर रही है, so we should try that it should cross the drainage at right angles. चाहे कैनाल ऊपर है या नीचे है. क्यों जी? Why?
से शॉर्टेस्ट डिस्टेंस कवर होगा इस तरह.
जी 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 जी, जो लेंथ ऑफ कंस्ट्रक्शन है वो हमारी मिनिमम होगी. अगर यूं ऑब्लिक लेके जाएंगे तो लेंथ बढ़ जाएगी. नंबर बी, वेल डिफाइंड क्रॉस सेक्शन ऑफ द रिवर, अ ड्रेनेज शुड बी अवेलेबल. तो जहां हम वो बनाना चाहते हैं क्रॉस ड्रेनेज स्ट्रक्चर, रिवर पाथ जो है, रिवर का क्रॉस सेक्शन वेल डिफाइंड होना चाहिए. नंबर सी, एट द क्रॉसिंग पॉइंट द ड्रेनेज शुड बी स्ट्रेट फॉर ए कंसीडरेबल लेंथ. वो रिवर जो है स्ट्रेट हो फॉर ए कंसीडरेबल लेंथ. ओके, otherwise you know that there are problems of concentration of flow. D, the width of drainage should be as narrow as possible. जहाँ रिवर की width कम हो, उधर भी हमें लेंथ ऑफ ड्रेन जो बनानी पड़ेगी क्रॉस ड्रेनेज स्ट्रक्चर की, वो कम होगी. So considering the above points, the cross drainage structure can be shifted to downstream or upstream. अगर हमें किसी एक खास जगह पे ऐसी चीजें नहीं मिल रही, we can slightly shift. And these again, you know, the selection of type of cross drainage works में जो availability of suitable foundations है, this already we have discussed. Economic considerations we have already discussed कि जो most economical solution होगा that we will provide. Discharge of the drainage, this we have already discussed, that if the discharge of the drainage is more, its width would be more and the cost of the cross drainage structure would be more. Construction problems, so there may be certain construction problems. कभी पानी आ जाता है ज़मीन में, उसके लिए हमें we have to do the dewatering etc. So that we have also keep in mind. Now we have to discuss the aqueduct types. एक्वेडक्ट तो हमने पढ़ लिया ना जी, क्यों जी?
Yes, sir.
What is an aqueduct?
When canal is overtaken the drainage and its bed level is higher than the highest flood level in the drainage.
High flood level in the drainage. Okay, very good. Now, what are the various types of the aqueduct? There are three types of the aqueduct. Aqueduct एक type 1 है, एक type 2 है और एक type 3 है. Okay. Now we want to discuss further classification of the aqueducts. Now, what is the type 1 aqueduct? एक्वेडक्ट जैसे आपने बताया कि जनाब वो है जिसमें कैनाल जो है वो क्रॉस कर रहा है टू द ड्रेनेज अबव इट इन सच अ वे दैट हाई फ्लड लेवल, ये हाई फ्लड लेवल यहाँ शो नहीं किया हुआ ना, ये हाई फ्लड लेवल है, इधर ये सीधी लाइन है भाई, थोड़ी टेढ़ी वेढ़ी हो गई है. सो दिस इज द हाई फ्लड लेवल और ये बेड लेवल ऑफ कैनाल है. सो बेड लेवल ऑफ कैनाल इज हायर देन द हाई फ्लड लेवल. ओके जी. What is then the type 1 aqueduct? Canal section, not flume. What do you mean by fluming? Fluming क्या होती है? Fluming means to reduce the width of the canal. That is called as fluming. Fluming क्यों की जाती है? क्यों भाई? कैनाल की विड्थ को कम क्यों किया जाता है? Over the drainage to reduce the cost of the hydraulic structure. ठीक है ना? फ्लूमिंग मीन्स टू रिड्यूस द विड्थ. पहले विड्थ ज़्यादा थी, अब फ्लूम करके कम कर दिया. तो ये जो टाइप 1 एक्वेडक्ट है इसमें फ्लूमिंग नहीं की जाती. सेक्शन जो पीछे से आ रहा है वही होता है. अच्छा, नंबर 2, अर्दन जो बैंक्स हैं ऑफ द कैनाल कंटिन्यूज थ्रू आउट द एक्वेडक्ट. जैसे पीछे से अर्दन बैंक्स आ रहे हैं वैसे ही ऊपर आगे से जा रहे हैं. ठीक है ना? ये जो एक्वेडक्ट है उसके ऊपर से भी यूं ही जा रहे हैं. सो ए लॉन्ग लेंथ ऑफ ड्रेन और ए वाइड विड्थ ऑफ एक्वेडक्ट इज रिक्वायर्ड. तो जनाब ये जो हमें एक्वेडक्ट की लेंथ है, दिस इज द लेंथ ऑफ एक्वेडक्ट. विड्थ ऑफ एक्वेडक्ट और कन्वर्ट लेंथ ये ज़्यादा चाहिए क्योंकि हम एम्बैंकमेंट वैसे के वैसे ही प्रोवाइड कर रहे हैं. ओके, किस लिए? टू अकोमोडेट द कैनाल एंड इट्स बैंक्स. So this is type 1 aqueduct. समझ आ गई भाई टाइप 1 aqueduct? Canal water is passing over the drainage such that the bed level of the canal is sufficiently higher than the high flood level in the stream. और जनाब इसके अंदर क्या हो रहा है कि फ्लूमिंग नहीं कर रहे, जो कैनाल की का डायमेंशन पीछे है वही ऊपर से जा रहा है एंड ऑल्सो जो एम्बैंकमेंट्स हैं वो भी वैसे ही जा रहे हैं. तो इसका मसला क्या हो गया? इसमें जो लेंथ है ऑफ द कर्वर्ट और विड्थ ऑफ एक्वेडक्ट रिक्वायर्ड इज लॉन्गर. ठीक हो गया? नाउ टाइप 2 एक्वेडक्ट. कैनाल सेक्शन नॉट फ्लूम. इसमें जो कैनाल की विड्थ है, बेड बॉटम विड्थ है, उसको कम नहीं किया जा रहा, वैसे की वैसे ही आ रही है. ये देखें, ये कैनाल सेक्शन इज सेम, वही जैसे पीछे से आ रहा था. Exterior side of banks of canal are replaced with retaining wall. अच्छा, ये जो बैंक थे बड़े हुए उसको हमने कम कर दिया और यहाँ रिटेनिंग वॉल्स दे दी. उससे का फ़ायदा क्या हो गया? द लेंथ ऑफ द ड्रेनेज पाथ थी, जो लेंथ ऑफ कन्वर्ट है या विड्थ ऑफ द एक्वेडक्ट है, दैट इज रिड्यूस्ड. ठीक हो गया? एज कंपेयर टू टाइप 1. सो दैट इज टाइप 2 एक्वेडक्ट. क्लियर है भाई? नाउ व्हाट इज द टाइप 3 एक्वेडक्ट? दिस इज द टाइप 3 एक्वेडक्ट. इसमें क्या है? कैनाल सेक्शन इज फ्लूम्ड. अब हमने क्या किया? कैनाल सेक्शन, कैनाल बड़ी चौड़ी थी, उसकी बेड विड्थ ज्यादा थी, वी हैव रिड्यूस्ड फ्लूम करके हमने उसकी विड्थ को कम कर दिया। क्यों कम कर दिया? टू रिड्यूस द कॉस्ट ऑफ द एक्वेडक्ट। अच्छा, पहली जो टाइप 1 और टाइप 2 में फ्लूमिंग नहीं की जा रही थी। ओके, सो कैनाल ट्रफ इज सपोर्टेड ऑन पियर्स एट सूटेबल डिस्टेंस। अब इसमें एम्बैंकमेंट जो थे, अर्दन एम्बैंकमेंट, वो नहीं है। देयर आर नो अर्दन एम्बैंकमेंट व्हिच वर ऑक्यूपाइंग अ लॉट ऑफ स्पेस ऑन बोथ साइड्स। इसमें क्या है? जस्ट ट्रफ है कंक्रीट की, और जिसकी वजह से द लेंथ of the culvert is reduced considerably. Okay, so ये बड़ी कम हो गई है। तो this is called as type 3 aqueduct, जिसमें हम फ्लूमिंग भी करते हैं। ओके, और ये ट्रफ है टू कैरी कैनाल वाटर, एंड दिस इज a slab, deck slab for the road, inspection road. So this one is the type 3 aqueduct. ठीक हो गया जी? तो कौन सी प्रोवाइड करनी चाहिए?
टाइप 3 सर, क्योंकि
टाइप 3 सर,
ऑलवेज
टाइप 3
ऑलवेज क्या ख्याल है? You know, if the drainage size is very small, तब भी टाइप 3 करनी है। अगर रिवर का साइज बहुत थोड़ा है ना? क्यों भाई?
नो सर, फिर टाइप 1 कर सकते हैं।
टाइप 1 कर सकते हैं। सो इट मीन्स वी हैव टू डू इकोनॉमिक एनालिसिस। हमें देखना है कॉस्ट किसकी कम है, सबसे जिसकी कम होगी दैट वी विल प्रोवाइड। अच्छा जी, अब आगे चलते हैं। सिलेक्शन क्राइटेरिया ऑफ फॉर टाइप ऑफ एक्वेडक्ट। यार कौन सी एक्वेडक्ट लगाएं? एक्वेडक्ट टाइप 1, एक्वेडक्ट टाइप 2, एक्वेडक्ट टाइप 3। कौन सी चीज कंट्रोल करती है इसको? इकोनॉमी कंट्रोल्स दी सिलेक्शन। भाई जो सबसे सस्ती है वो प्रोवाइड कर दें। अच्छा जी, इन टाइप 1 नो विंग वॉल्स, बैंक कनेक्शंस आर रिक्वायर्ड। भाई जैसे पीछे से रिवर इस कैनाल बैंक्स आ रहे थे वैसे ही जा रहे हैं ओवर दी स्ट्रीम। So as section of the canal and embankment is not changed, however a longer drain length is required. ठीक है ना? Number, so type 1 is suitable for small length aqueducts. बात समझ आ गई है? जहाँ पे जो ड्रेन्स की विड्थ है ना वो थोड़ी है, वहाँ पे ये अच्छे ठीक रहेंगे। एंड वेयर कॉस्ट ऑफ विंग वॉल्स एंड कनेक्शन इज लार्ज, तो वहाँ पे आपने ना विंग वॉल देनी है ना कनेक्शन देने हैं। ठीक है ना? इन केस ऑफ टाइप 1। टाइप 3 एक्वेडक्ट इज सूटेबल इफ लेंथ ऑफ एक्वेडक्ट और विड्थ ऑफ ड्रेन इज टू लॉन्ग। अगर रिवर बहुत बड़ी है जिसको मैं क्रॉस कर रहा हूँ, ऊपर कैनाल ले जा रहा हूँ उसके, तो फिर आई हैव टू प्रोवाइड टाइप 3 एक्वेडक्ट। तो फिर ये जस्टिफाई होगी बाय रिड्यूसिंग कॉस्ट ऑफ विड्थ ऑफ द एक्वेडक्ट। अब मैंने उसकी कम कर दिया, या लेंथ ऑफ कल्वर्ट कम कर दिया। ठीक है? एंड टाइप 2 इज इंटरमीडिएट। नाउ कम टू ट्रांजिशंस। व्हाट इज ट्रांजिशंस? टाइप 3 एक्वेडक्ट में व्हाट वी आर डूइंग? वी आर डूइंग फ्लूमिंग। हम फ्लूमिंग कर रहे हैं। जो कैनाल की पहले बेड विड्थ थी वो ज्यादा थी, उसको फ्लूम करके कम किया है। तो जब मैं फ्लूमिंग करूंगा तो शैल आई डू एब्रप्ट फ्लूमिंग? मुझे एब्रप्ट करनी चाहिए, ग्रेजुअली करनी चाहिए?
ग्रेजुअली।
So I have to change the width of the canal and change the shape of the canal gradually. देखें, पहले कैनाल की शेप क्या है? ट्रेपेजॉइडल, है ना? उसकी बेड विड्थ ज्यादा थी। फिर हमने क्या किया? अब शेप ट्रफ की क्या कर दी? रेक्टेंगुलर, और उसकी विड्थ भी कम कर दी। सो आई हैव टू रिड्यूस द विड्थ एज वेल एज आई हैव टू चेंज द शेप फ्रॉम ट्रेपेजॉइडल टू रेक्टेंगुलर। तो मुझे ग्रेजुअली करनी है, एंड फॉर डूइंग दैट आई हैव टू प्रोवाइड ट्रांजिशंस। तो ट्रांजिशन मैंने कितने प्रोवाइड करने हैं भाई? 2।
सर 2।
एक इनलेट पे फिर जब रिवर नीचे से पूरी होगी लेंथ, तो फिर मैंने क्या करना है, आउटलेट पे एक ट्रांजिशन प्रोवाइड करना है. दिस इज इनलेट ट्रांजिशन, ये दिस इज ट्रफ एंड दिस इज आउटलेट ट्रांजिशन. इनलेट ट्रांजिशन का दूसरा क्या नाम है, कॉन्ट्रैक्शन ट्रांजिशन. क्यों भाई, विड्थ को कॉन्ट्रैक्ट कर रहे हैं ना. अच्छा, आउटलेट ट्रांजिशन का दूसरा क्या नाम है, एक्सपेंशन ट्रांजिशन. अब हम एक्सपैंड कर रहे हैं ना, बढ़ा रहे हैं विड्थ को. So a transition is a structure designed to convey water smoothly from a channel of one shape to another or different shape. ठीक है, एक तो शेप और एक दूसरा साइज. इसमें साइज भी आएगा, साइज को भी कम कर रहे हैं ना, शेप और साइज. A common application is between a canal and a flume, also between open channels and inverted siphons. वहाँ पे भी हमें ट्रांजिशन चाहिए. जब हम साइफन प्रोवाइड करते हैं तो तब भी हम उसकी विड्थ कम कर देते हैं. इनलेट ट्रांजिशन को कॉन्ट्रैक्शन ट्रांजिशन कहते हैं, जब वहाँ लार्ज से स्मॉल की तरफ हम जा रहे हैं. और आउटलेट ट्रांजिशन को एक्सपेंशन ट्रांजिशन कह रहे हैं, तो हम स्मॉल विड्थ से बड़ी विड्थ कर रहे हैं, तो लार्ज कर रहे हैं. नाउ व्हाट आर देयर टाइप्स. The simplest type of transition is a straight wall normal to flow direction. ये, और मैं एकदम स्ट्रेट वॉल ऐसे दे दूं, ये बात समझ आई है मैं नहीं, मतलब दिस इज द बेड विड्थ ऑफ द कैनाल. अब मैं क्या करूं, ये मैं ट्रांजिशन दे दी, ये मैंने स्ट्रेट वॉल बना दी, तो ये तो एब्रप्ट हो गया, एब्रप्ट ट्रांजिशन है ना. सो ऐसी ट्रांजिशन जो है उसमें हेड लॉस बहुत ज़्यादा होगा. सो वी डोंट प्रोवाइड सच एब्रप्ट ट्रांजिशन, वी प्रोवाइड ग्रेजुअल ट्रांजिशंस. सो ग्रेजुअल ट्रांजिशंस आर यूज्ड टू प्रिवेंट एक्सेसिव हेड लॉसेस को कम करने. तो कॉमन टाइप ऑफ ट्रांजिशंस कौन सी हैं, सिलेंडर क्वाड्रेंट ट्रांजिशन है, वेज ट्रांजिशन है, और वार्ट वॉल ट्रांजिशन है. दैट वी वांट टू सी हियर. So this is a cylinder quadrant transition. So this is a quadrant of a circle, ठीक है, of radius r. ये वाली क्या है, this is the canal and this is the trough vertical wall. तो अब this transition is called as cylinder quadrant transition. ये कहाँ प्रोवाइड किया जाता है, for small discharges. If the discharges are up to 300 cusecs of the canal, ठीक है, तो हम सिलेंड्रिकल और स्ट्रेट और वेज टाइप इज सूटेबल. दूसरी कौन सी है, वेज टाइप ट्रांजिशन. वेज, दिस इज ए वेज. तो दो वेज इधर प्रोवाइड कर दिए हैं और इधर से यहाँ से इट इज कनेक्टेड लाइक दैट. सो ट्रेपेजॉइडल शेप इज चेंज टू रेक्टेंगुलर बाय दिस. और ये भी हम कितने डिस्चार्जेस तक यूज करेंगे, अप टू 300 क्यूसेक्स. देन वार्प ट्रांजिशन. वार्प ट्रांजिशन में हमने क्या करना है कि जो वॉल है उसको मोड़ते जाएंगे. वो पहले इंक्लाइन थी बट आगे भी लेते जाएंगे, इसकी विड्थ भी कम करते जाएंगे और वर्टिकल भी करते जाएंगे. सो हियर यू कैन सी द वॉल इज वार्प्ड. यहाँ पे इसका वही स्लोप है जो पीछे था, आगे वर्टिकल होता जाएगा एंड हियर इट इज फुल वर्टिकल. सो इट इज ग्रेजुअली. सो if the discharge of the canal is more than 300 cusecs, so we provide warp transition. Okay, so it covers about 80 to 90% of the difference of velocity head if they are properly designed. यानी कि इसमें head losses are minimum in this warp transition. So these are the enlarged sketches of cylinder quadrant transition, wedge transition. This is wedge transition and this is warped wall transition. तो ये देखें, ये cylinder quadrant है and this is the wedge shape and this is the warped wall transition. So this is the most efficient one. So now we have to discuss the methods for designing a warped transition. देखें, पहले हमने aqueduct को discuss किया. Then we discuss the types of aqueducts. Type 1, Type 2, Type 3. Type 3 में transitions आ गए. Fluming करनी पड़ती है हमें. जब फ्लूमिंग करते हैं तो फ्लूमिंग के लिए वी हैव टू गिव ट्रांजिशंस, इनलेट और आउटलेट ट्रांजिशन देने पड़ते हैं. जब वो ट्रांजिशंस देने पड़ते थे देन वी डिस्कस द टाइप ऑफ ट्रांजिशंस. तो वो हमने डिस्कस किए कि जनाब वो क्वाड्रेंट जो है ना, सर्किल ट्रांजिशन हो सकती है, सिलेंडर हो सकती है, वेज हो सकती है और वार्प वाल हो सकती है. अब ये है कि अगर ये वार्प वाल ट्रांजिशन है तो उसके मेथड्स क्या हैं? व्हाट आर द मेथड्स फॉर डिजाइनिंग वार्प्ड ट्रांजिशन? तो जनाब उसके ये 3 मेथड्स हैं. नंबर 1 इज द मित्राज मेथड. ये कब हम यूज करेंगे? व्हेन वाटर डेप्थ रिमेन्स कांस्टेंट. जो पहले डेप्थ ऑफ फ्लो थी वही डेप्थ ऑफ फ्लो ट्रफ के अंदर भी रखना चाह रहे हैं, सो वी मे यूज मित्राज मेथड. दूसरा है चातर वेदीज मेथड. ये भी व्हेन वाटर डेप्थ रिमेन्स कांस्टेंट. जो चैनल में डेप्थ है द सेम इज द डेप्थ ऑफ फ्लो इन द ट्रफ, कंक्रीट ट्रफ. एंड द नेक्स्ट इज हिंस मेथड. ये ट्रांजिशन कब हम डिजाइन करेंगे? व्हेन वाटर डेप्थ मे और मे नॉट वेरी. अगर हम डेप्थ को चेंज करना चाह रहे हैं इन द कंक्रीट ट्रफ then we may use hints, but these two, if we want to keep the same depth of flow as it is in the channel. Okay, and so Mitra's method that we will discuss next time, and after discussing the Mitra's method then we will solve a numerical, and that would be the end of this chapter. So till now, if you have any questions, you are welcome. Yes. So questions are welcome. कोई है जी सवाल?
नो सर.
नो सर.
Okay. Okay, then thank you very much. Wish you best of luck. Okay, Allah Hafiz.